Hello everyone and welcome to my channel Aptitude Club. Hope all of you are doing well. So today in this video we'll be discussing a question on the topic removal and replace. This belongs to the topic removal and mixture alligation area. Very important topic in terms of expectancy of the cat. Questions being asked from this. Once again, I'll request all of you watching this pause at this moment. Try this question first. So what the question is saying is a container contains pure milk. 10% of this is removed and replaced with 25% is then removed and replaced with water. Finally, 30% is removed and then replaced. What is the percentage of milk in the final? So I'll give you some context. If you understand removal replacement, this is a very easy question to solve. Those of you who are not aware of removal replacement, I'll just explain. There is a formula case of removal and replacement. It is F is I whole into 1 minus x by L for n, where I can write F as the final quantity or concentration. I means the initial quantity or concentration. Then X is the quantity removed and replaced. Removed and replaced. L is the quantity of the container where you are doing this operation. And N is the number of repetitions. Now, for an example, suppose there is this container like this of 100 liters. And from this, every time you are removing 10 liters and you are replacing with 10 liters of water. The container has 100 liters of milk. You are removing 10 liters and adding 10 liters of water. And you are doing this process 3 times, let's say 5 times, or let us say 10. In that case, I will take as 100, X I will take as 10, L I will take as 100, and N depends on the number of times. Let's say 3 times, 5 times. And if you solve that, you will get the value. But this formula is applicable if you remove and replace the every time. Removing and replacing the same every time. That means I'm removing 10 and replacing. Again removing 10, again replacing 10. Every repetition I'm doing, but this formula can be slightly modified that I'm removing and replacing the same thing, but I'm not doing the same thing every time. Like for an example, first time I remove 10 and replace 10. The second repetition I'll remove 20 and replace 20. The third repetition I'll remove 30 and replace 30. Although the overall quantity is same, but every repetition is being done different. So in that case, the formula structure will remain same. This will just slightly be modified like this: 1 minus x1 by L, 1 minus x2 by L, 1 minus x3 by L, where x1, x2 and x are the quantities removed and replaced. Everything else remains. This particular question will be using the second formula, because if you read again the question, first I am removing 10%. 10% means 1/10. Then I am removing 25%, which is 1/4, and then 30%, which is, so I am removing and replacing the same thing. The repetition will just clearly write this formula and then substitute. F is I whole into 1 minus x1 by L, 1 minus x2 by L, 1 minus x by L. Now if I look at this, container contains pure milk. Initially I have 100% milk, so I'll use I as 100%. Then 1 minus x1 by L. We don't know the exact capacity of the container, but it is saying 10% is removed. That means x1 by L, 1/10, 10%. Similarly, x2 by L, 25%, which is 1/4, and x3 by L, 30% is removed and replaced. 30% means by 10. So I can use these values and substitute here. So first 1 by 10, second time I am replacing and removing 1/4, and third time 30%. So just we need to solve this full process. Once you understand the formula, it is very easy to 3 by 4 into 7 by 10. 9 into 3, 27 into 7, 180 by 4%. 189 by 4 is 4, 4, 6, 47.25% milk. This is like the final concentration of milk. 47.25% is milk. I can write 52.75% water. The final like resultant ratio is 47.25 milk, 57.7, 52. Overall, it is 100. What is the percentage of milk in the final solution? 47. And direct formula based. This removal replacement, there are three types of questions. This is category 2. I'll make a detailed separate video on removal replacement. Understand the entire concept. How is this formula derived? I'll also explain that. So stay tuned for that video. But I hope you understood the explanation. That is it for from this video, and we'll meet again. If you are new to the channel and you have watched it this far, do subscribe to the Aptitude Club channel if you like to explore the previous videos that I have discussed. And keep solving, keep studying, and thanks for watching.